students. Now today we are going to learn about the one of the most important unit, that is a ninth unit from your computational botany sixth paper. The name of unit is Computation of a Seed Testing and Plant Growth Analysis. Here students, you have to keep in mind, we should first of all know how to calculate the seed germination, or before that one we have to understand about the what is seed germination. Actually, development of seedling from a seed is known as a germination. Development of a seedling from the seed is known as a germination. It is the process in which the seed sprouts for growing and developing into a sprouts for growing and developing into the plant. The germination percentage calculated approximately of the viability of the population of the seed. What is viability? Viability is nothing but the ability of a seed to germinate. That is nothing but the viability. Or we have to say that the ability of a seed to develop into the seedling. That maybe we can say that. The germination rate provides a measure of the time course of seed germination. So there is one of the most important formula that you have to remember for the calculation of a germination percentage. How to calculate that one? The number of seeds germinated divided by number of seeds we have put for the germination in the tray multiplied by 100. Multiplied by 100. Example I will give to you, isn't it? Suppose in the petri plate we have put 100 seeds for the germination. And on third day we saw that there is a sprouting to the 25 seeds out of 100, 25. So number of seeds germinated is a 25 divided by number of seeds we have put into the tray for the germination, in petri plate for the germination, 100 multiplied by 100. So 100 cancel, so 25% seeds are germinated. So like that one, we can calculate the germination of a percentage of a seed with the help of this formula. So number of seeds germinated divided by number of seeds put for the germination. Suppose we have put the 50 seeds into the petri plate and out of that one 25 germinated. Then what is the percentage? Definitely 50%. So how to calculate? The seeds germinated number is 25. Total number of seeds put for the germination into the tray or in petri plate, that is of a 50. So 25 divided by 50 multiplied by 100. Now 50 when we divides to the 100, then that is the 2 is there. So 25 multiplied by 2, that is equal to 50. So this is the formula of a now mean germination time. How to calculate that mean germination time? Mean germination time is also described as the length of the light period from the start of the imbibition to a radical protrusion. Mean germination time was first calculated with the help of a formula, that is of a Ellis and Robert in 1988. The mean germination time, that is equal to the summation of n into d divided by summation n. What is n? N is nothing but the number of seeds newly germinated at d time. D, that is the days from the beginning of the germination test, and summation n, that is equal to final germination. So this is the formula you have to remember just to calculate the mean germination time. That a mean germination time formula is equal to summation n into d divided by summation n. Now germination index. So germination index, what is that, or what is the formula which we have to use for that one? Summation, that is gt divided by, in bracket, small tt. This is the formula which is given by Zucconi and et al. In 1981. So his co-workers were there just to develop this formula. The germination index was first introduced by Zucconi et al. 1981. According to them, allowed to evaluate at both the low level of a toxicity that affects the root growth as well as the high toxicity of the level of the toxicity which affects the seed germination. So here GT is the number of seeds germinated on a tray day T. Suppose we have taken the reading of our experiment on second day. So on second day, how many seeds have been germinated? That number you have to write, isn't it? And it is the number of days, and TT is the number of days. You have to keep in mind TT is the number of days. Okay. Now, germination speed formula is here. Speed of the germination of the seed we can calculate with the help of N1 divided by D1 plus N2 divided by D2 plus N3 divided by D3. So N1 divided by D1 plus N2 divided by D2 plus N3 divided by D3 plus dash dash, where N is the number, where N is the number of germinated seed is there. N1 divided by D1 in the sense number of seeds germinated on first day divided by day number 1, isn't it, like that one? So we have to make total, that is how long that experiment has been carried out, that you have to make the sum of that one. N1 divided by D1 plus N2 divided by D2 plus N3 divided by D3, like that one speed of germination can be calculated. So example I will tell to you. Suppose on the 5th day, out of 50, suppose there's 25 seeds germinated on 5th day. So speed of germination of a seed, we can say that on 5th day 50% seeds are germinating there. And suppose we have continued that experiment, and on 30th day we have found that 30th day we have to say that we have found that 100% seeds are germinated. So that is a long period. So before that, why to study all these things? We are interested in case of, first of all, seed should get germinate immediately I have to say that, and then establishment of that seed or development of that seed into the plant, or we have to say that the tree is there, isn't it? So these parameters are having a lot of importance. Speed we have to see. So accordingly, suppose we know that the seed should germinate within a week, and suppose we know that actually 50% are germinating within a week. Suppose we have sown the 1 kg seeds into a 1 acre area. 1 kg seeds into 1 acre area, and 50% seeds are germinating, isn't it? So that is the speed of germination on within a week, we have to say. And suppose we want to germinate at least 100%, crop should be there. So we have to again sow 2 kg per acre, we have to say that, isn't it? So these things are there to the farmer, useful to get germination of a seed in a proper time, and again growth of that crop into a proper time, and yield of that one. Now vigor index, isn't it? How to calculate the vigor index? Very simple formula for vigor index is there. Actually, that is a calculated by multiplying germination percentage and seedling length. Here we will be able to see that germination percentage is given 94, and seedling length, that is in mm, and multiplication 94 into 82, that is equal to 7708. 87 germination percentage is there, and 79 is seedling length in mm is there. Multiplication of this value is 6873. So vigor index can be calculated by multiplying germination percentage and seedling length in mm. Now, seed germination and early seedling growth under the stress. Stress in the sense that is well known to us whenever the plants are growing under the high salinity, high, we have to say that the temperature, then again high flooding conditions are there, and again we have to say that there is a cold temperature. So these are the stresses. Disease also causes the stress to the plant. Here This promptness index was calculated using the formula proposed by Bouslam and Shekapog. Shekapog, who they have given in 1984. Promptness index pi, that is equal to n d2 in bracket 1.01 plus nd4 in bracket 0.8 bracket complete plus nd6 in bracket 0.6 plus nd8 in bracket zero point 0.4 bracket plus. So like that, when this formula is there, the percent of germination speed after 2, 4, 6, 8, 10 days after sowing respectively seeds. So this is the promptness index formula we can use here. Now germination stress tolerance. Already I have how to calculate the stress tolerance. That is, germination stress tolerance percentage can be calculated with the help of simple formula, that is uh, percentage of stressed seeds divided by percentage of a controlled seeds into 100. Keep in mind, friends, suppose we have a setup one of the experiment of a germination. There are a 100 seeds in a petri plate, isn't it? That, and we have germinating that seeds into a 0.1% NaCl solution. So same day, same way, with same manner, we have to set up another petri plate with 100 seeds, isn't it? And that we have to consider as a control, because there is a no any type of a NaCl is added into the solution which we have to use it for the germination of a that petri plate. So control in the sense, no any salt solution we have given to the first petri plate, that is control. Second, that is of a treated with the 0.5% of a NaCl solution. Now we have to take the readings. The percentage of stressed seeds. Out of 100, suppose only 5 seeds have been germinated, which are treated with the 0.5% NaCl. So that 0.5%, 5 seeds germinated, in the sense 5% seeds are germinated into a 0.5% treated NaCl solution. That is a 5. And in control, there is a 10. So 5 divided by 10 multiplied by 100, that is equal to 50. That is equal to 50, isn't it? So germination stress tolerance can be calculated with the help of this formula. The germination seeds germinate, percentage of seeds germinated into stress divided by percentage of seeds germinated into control. Now shoot length stress tolerance. Shoot length stress tolerance can be calculated by shoot length of treated seedlings divided by shoot length of control into 100. Shoot length of a stressed or treated seedling divided by shoot length of a control seedling into 100. Now similar way, here we can see root length stress index. How to calculate the root length stress index? Root length of treated seedling divided by root length of control seedling into 100. Dry matter stress. Dry matter of a stressed plant divided by dry matter of a control plant multiplied by 100. So these are the formula you have to remember, and it would be a better, my friends, if you could set up one of the experiment, calculate according to that one, and then you will come to know that the use of this formula, how to calculate the root length stress tolerance. When we want to calculate the stress tolerance, at that time we have to first of all take the percentage of the seeds, percentage of or we have to say the root length of the treated seedlings, and that is to be divided by root length of control, which we have maintained simultaneously, multiplied by 100. That is nothing but the root length stress tolerance. So with this, thank you very much, my friends.